Have you ever wondered what lies at the bottom of the deepest well in the universe? What happens when you fall into a place where not even light can escape? These are not just questions for science fiction. They are real questions about real places in our cosmos. We call them black holes. They are perhaps the most mysterious and extreme objects in all of existence. To journey into one would be the ultimate adventure. It would also be your very last. So let's take a trip of the imagination. Let's see what happens when you take that final, fateful plunge into the dark. A black hole is what's left behind when a truly massive star dies. Imagine a star many times bigger than our own sun. At the end of its life, it collapses under its own tremendous weight. All of its matter gets squeezed into an impossibly small space. This creates a gravitational field so powerful, so intense, that nothing can break free. It's not a hole in the sense of being empty. It's actually the exact opposite. It's an incredible amount of stuff packed into a tiny point, a point we call a singularity. It is a place where our known laws of physics simply break down. The black part of its name is quite literal. Light travels faster than anything else in the universe. Yet even light cannot escape a black hole's grasp. Once light crosses a certain boundary, it's trapped forever. This boundary is called the event horizon. Think of it as the edge of a cosmic waterfall. Before you reach the edge, you might still be able to paddle away. But once you go over, there is no turning back. The darkness of a black hole is the color of a one-way trip. It is the color of a place that consumes light itself. This cosmic monster doesn't just sit there quietly, though. Its gravity is so immense that it pulls in surrounding gas, dust, and even entire stars. This material spirals inward, forming a glowing superheated disk around the black hole. This is called an accretion disk. It blazes with incredible energy, shooting out jets of radiation. It's a cosmic lighthouse warning of the danger within. So while the hole itself is black, its neighborhood can be one of the brightest places in the universe. It is a beautiful, violent, and mesmerizing spectacle, a cosmic dance of creation and destruction, all on the doorstep of oblivion. Let's imagine you are an astronaut in a resilient spaceship. You decide to get a closer look at a black hole. From a safe distance, you see the strange effects of its gravity. The light from the stars behind it appears bent and distorted. Space itself is being warped, like a bowling ball on a trampoline. You are witnessing Einstein's theory of relativity in action. The fabric of space-time is curving around this massive object. This cosmic funhouse mirror is your first clue. You are approaching a place where the rules of reality are different. A place that plays by its own, extreme set of laws. As you get closer, something strange begins to happen to time itself. This is another prediction of Einstein's work. Intense gravity slows down time. For you, inside your ship, everything feels normal. Your clock ticks at its usual pace. But for an observer watching you from far away, your journey seems to slow down. The closer you get to the black hole's event horizon, the slower you appear to move. It would be like watching a movie in extreme slow motion. Your friend back on Earth would watch you for years, decades, even centuries. You would seem frozen in time. From your perspective, the universe outside your window speeds up. You would see the future of the cosmos flash before your eyes. Stars would be born and die in the blink of an eye. Galaxies would swirl and collide. It would be the ultimate fast-forward button. You are on the fast track, while the rest of the universe seems to be in a hurry. This effect is called gravitational time dilation. It is one of the most mind-bending consequences of gravity. You are a time traveler, but only into the future. And your destination is not a different year, but a different kind of eternity. The view becomes even more spectacular. The black hole fills your vision, a perfect circle of pure blackness. It is framed by the swirling, hot gas of the accretion disk. The light from this disk and the stars behind you is warped into strange arcs and rings. You might even see the back of your own head. Light from behind you can travel all the way around the black hole and come back to you. It's a dizzying, beautiful, and terrifying sight. You are witnessing the raw power of gravity, bending not just space, but light itself. You are on the threshold of the unknown. Now you make the final decision. You point your ship directly at the black hole and cross the event horizon. For you, there is no drama. No bang, no wall, no jolt. You simply float across this invisible line. It is a point of no return defined only by mathematics, not by any physical barrier. One moment you could escape. The next moment, you cannot. From your perspective, you are simply continuing your fall. But you have sealed your fate. You are now inside the black hole. You are cut off from the rest of the universe forever. An outside observer, however, would see something completely different. To them, you would never actually cross the event horizon. As you approached it, your image would appear to slow down more and more. It would get dimmer and redder. This is because the light leaving your ship loses energy as it fights the black hole's gravity. It gets stretched to longer, redder wavelengths. Eventually, you would appear to freeze at the edge, fading away over an infinite amount of time. Your friend would watch your ghost image remain there forever, a permanent fading monument at the edge of space and time. But you are not frozen. You are falling and falling fast. Inside the event horizon, space and time swap roles in a very strange way. In our normal lives, we can move freely in any direction in space, but we are forced to move forward in time. Inside a black hole, this is reversed. The singularity is no longer a place in space. It is a moment in your future. You can no more avoid hitting the singularity than you can avoid next Tuesday. All possible paths, every direction you could possibly move, lead to the center. The pull is inevitable. So what do you see? Looking back, you might be able to see the entire universe you left behind. It would be contained in a shrinking circle of bright, blue-shifted light above you. Blue shifted because you are falling into it so fast. It would look like a window to all of space-time. Looking forward, there is only darkness, complete and utter blackness in the direction of the singularity. You are trapped between the past and the inevitable, a silent one-way journey into the heart of a collapsed star. Your ship is now a submarine in an ocean of warped space-time, and the pressure is building. As you plunge deeper, you begin to feel a strange sensation. The immense gravity of the black hole starts to pull on you unevenly. Imagine the black hole's singularity is below your feet. The gravitational pull on your feet is much, much stronger than the pull on your head. This difference in gravity is called a tidal force. On Earth, the moon's tidal forces create our ocean tides. But near a black hole, these forces are magnified to an unimaginable degree. They will stretch you. They will pull you apart. This process has a grim but descriptive name: spaghettification. The tidal forces pull on your body, stretching it vertically. At the same time, they squeeze you horizontally. You would literally be drawn out into a long, thin strand of atoms. Like a piece of spaghetti. It would not be a pleasant experience. Your body would be elongated, thinner and thinner, until you are just a stream of subatomic particles. You would be deconstructed atom by the raw power of gravity. This is the fate that awaits anything that falls into a smaller, stellar mass black hole. For a supermassive black hole, the kind found at the center of galaxies, the story is a bit different. The event horizon is much farther from the singularity. The tidal forces at the edge are gentler. You could actually cross the event horizon without being immediately torn apart. You might have minutes or even hours of a relatively peaceful fall, but your fate would be the same. As you get closer to the center, the tidal forces would increase exponentially. Spaghettification is inevitable. It is the final, violent act of your journey. What happens to that stream of particles at the singularity? We simply don't know. Our two best theories for describing the universe, general relativity and quantum mechanics, don't agree on what happens there. Does matter get crushed out of existence? Does it emerge somewhere else in another universe? Is it the beginning of a new cosmos? These are some of the biggest unanswered questions in science. Black holes represent the limit of our knowledge. They are cosmic laboratories where the laws of nature are pushed to their breaking point, and they continue to inspire our wonder and our relentless quest for answers.